Welcome. So we're looking at Chapter 6 today here in this video. And so Chapter 6 deals very specifically with a type of model that looks at and tries to explain growth, long-run growth in the economy. So as I've mentioned in previous chapters, the first third of the book or so of Michigan's macroeconomics textbook looks specifically at thinking about the economy from a long-run viewpoint. Now, this chapter and the chapter that follows in Chapter 7 look at the economy from a very long-run viewpoint. And so the main purpose of this of the chapter really is to try to explain why and how countries grow over long periods of time. And so in particular, the idea is to think about how you can see changes or variation rather in the growth rates of some countries relative to another. So the underlying intuition behind this model is really to get at understanding the fundamental institutional factors of why economies grow faster than others, and ultimately what determines the standard of living for an economy. And so we're going to be measuring the standard of living in terms of thinking about output per person, or as in this model, the Solow model, thinking about it in the context of output per worker. Output per person or per capita and output per worker are essentially the same thing. They're just, the output per worker is a proxy for output per capita. And so to motivate, sorry, just to back up a second, again, as I mentioned before, we're thinking about the economy in the very long run. And so again, to think about this from a time perspective, the idea is not thinking about over a 1 or 2 year period. We're thinking about periods over several years, or even more so, potentially decades. So thinking about over long periods, decades and decades and decades, what explains the increase in the standard of living in the U.S., what explains increases in the standard of living in Canada or Mexico or any other country. That's what we're thinking about, is over a very long time frame. What are the institutional frameworks and pieces in place that allow us to explain this growth? To motivate this question, we can look at this diagram, which gives GDP per capita over a really long period of time. And so a couple of things pop out of, of this diagram. First of all, you can see countries like, for instance, South Korea, China, and India stick out. And those are the countries that have grown very rapidly, again, in comparison to other countries. If, in particular, if you look at South Korea back in 1960 started out at a relatively low standard of living, but they were able to reach escape velocity, and by the 2000s, their standard of living is up there close to the US, the UK, Japan, and many other of the industrialized first world countries, so to speak. And so that's a prime example of trying to understand how does a country like South Korea get from point A to point B, and what are the underlying fundamentals behind that. And in addition, we can think about, as I said, China and India more recently have started to reach escape velocity out of that. And then the other issue, again, is thinking about, well, why do these poor countries stay poor? So this model, the Solow model, is a first step at trying to understand why and how some countries that are poor stay poor, and why and how some countries who perhaps were poor are now rich, so to speak, in terms of thinking about that in the context of the standard of living. So the fundamental idea, again, gets back to the economics behind it and our production function. So we have inputs in a production, and that spits out output. That output is income to the economy. And so in a lot of ways, the production function really is going to be dictating, in some sense, how well off an economy is. And so if we look at the basic Cobb-Douglas production function that we've seen previously, we have output is equal to that A parameter, which is total factor productivity, times K to the 0.3, L to the 0.7. And so, not surprisingly, you can see just by inspection of this production function, if we increase either the A parameter, total factor productivity, capital, or labor, holding everything else constant, total output produced is going to rise. So in some sense, that gets us to thinking about, well, you know, that might in some sense lead us to believe that any of those three things increasing means we're going to be better off. But there's one warning that we have to, or caveat that we have to underscore here, which is that that doesn't necessarily mean society is better off. And now when we talk about standard of living, talk about economies being better off, we're talking about this in the context mostly of output per person or output per worker. Okay, and we'll talk about why this is here in a minute. So we're going to measure our standard of living in terms of the amount of output per person. And as I mentioned before, this is going to be proxied by output per worker. Because we're using the production function to think about what goes into it and what comes out of the economy and in terms of income, it's really easy to think about it in terms of per worker measures. And as I said, there's going to be a pretty close correspondence between output per capita and output per worker, as long as things like long-term labor force participation remain relatively constant. So to give you some thinking about this production function and how that relates to output and standard of living, it's not too hard to see that when the capital stock rises, if we hold total factor productivity and our labor force constant, total production is going to rise, and that therefore means output per worker is going to go up. That means the economy is better off as a result. So again, in better off standards, we mean better off in terms of an increased standard of living. Again, when A increases, total factor productivity, again, if we hold everything else constant, if we hold capital and labor constant, what that means is that, again, we're going to produce more output. If we're holding labor constant, more output with labor constant means output per worker is going to rise. So again, that suggests that the standard of living for an economy is going to increase. But when our labor force increases, again, if we hold TFP and our capital stock constant, it turns out that output per worker is actually going to go down. And so what that means really is that our standard of living in that economy, the amount of output per worker or output per person as a proxy, is going to decrease. And essentially it comes down to thinking about diminishing marginal returns to labor. And so to give you a better insight into this, if we again look at our production function, we have this basic production function, and we can transform this in the following way. We can approximate the percent change in output as equal to the percent change in A plus 0.3 times the percent change in K plus 0.7 times the percent change in L. Okay, so that's a first approximation in growth rates to this level, this production function in levels. Now, I'm not going to go into details about why that is or where it comes from. It's discussed a little bit in the book. But if we take this for granted, then what that means is that if we think about this thing being the growth rate of output, G sub Y, the percent change in A, G sub A, percent change in K, G sub K, percent change in L, G sub L, okay? This gives us what's referred to as the growth accounting equation. And so basically this outlines the various sources of growth in total production. You can get it through growth in technology, growth in the capital stock, or growth in the labor supply, okay? Now the implication for this is the following. Suppose we increase, excuse me, suppose we increase the growth rate of technology or TFP by 1%. Well, an increase in TFP, the growth rate of TFP of 1%, that's going to lead to a 1% increase in the growth rate of total production. You can see it right there in this growth accounting equation. There's a 1-for-1 direct correlation between growth in TFP and growth in total production. As it turns out, that's going to be an important source of underlying growth for economies, and which we'll talk about a little bit later on. If we look at capital stock, again, a 1%, excuse me, a 1% increase in the capital stock is going to lead to a 0.3% increase in total production. So if we grow the capital stock, total production is going to rise. Now, we don't get as much of a bang for the buck as we do from direct increases through total factor productivity, but nonetheless, there's still an increase in total output produced. And so we still have a better standard of living because holding everything else constant, including the labor force and population, if total output is rising and labor force is constant, then you would expect to see an increase in the standard of living. So overall, the standard of living in terms of output per person or per worker should rise. And then lastly, if we get, again, if we assume a 1% increase in the growth of the labor supply, it turns out we're going to be worse off as a society as a result. And so again, you can see that here, with an increase in the growth rate of the labor supply of 1%, the growth rate of output is going to go up, but it's going to go up by 0.7%, okay? And so what that means is that even though output, total production rises, it rises less than the increase in labor. And so overall, the intuition is such that you're producing more output, but you have more mouths to feed. So it's going to be, that increase in output is going to be spread across more people in the economy. So overall, the output per person or output per worker is going to be lower. And so that gets at the heart of this issue of thinking about standard of living, is that just accumulating more labor increases production, but it doesn't help you in terms of standard of living. In fact, it makes it worse. And so again, the idea here is that there's these three separate channels through which we can think about growing the economy in terms of total production, okay? And so we can grow it through growth in the labor force, we can accumulate more workers, and as we just noticed, that's a lousy way to grow an economy, because at the end of the day, that actually reduces your standard of living rather than increases it, because you have greater production, but you have more mouths to feed, so it dilutes that production due to diminishing marginal returns to labor. The second channel is through growth in technology, as I mentioned, and so as I said before, that's an important driver of growth and increases in living standards over time. So that's a way that we can see sustained growth in our standard of living over time, and that's something that is dealt with in Chapter 7. And then the third channel is this capital accumulation story. So as we accumulate more capital, that allows us to increase the efficiency of our workforce. And so again, the intuition is such that if we have a pool of workers and we give them more machinery to use, then that existing pool of workers is going to be able to produce more output with the existing inputs, and so therefore you're going to be able to produce more output per worker, and our standard of living is going to rise. And so again, that's another important channel through which economies can grow and improve the standard of living, is simply by capital deepening, is what they call it, increasing the amount of capital that the workforce has available to it. So we're going to focus on this story of improving the standard of living, and that's going to be the main thing that we're trying to understand. What are the factors that'll help us understand improvements in the standard of living over time? And so as I said, we're going to measure this as output per person, okay? And so this is going to be a direct proxy to output per capita or output per worker. So those things are all going to be synonymous in this framework. So when you see Y, capital Y over L, output per worker, that's going to be the same thing as output per person or output per capita. And so we're going to denote the total amount of output per worker as this little y. So any small cap letters you see are the total production counterpart to that divided by the workforce. So in other words, if we have this Cobb-Douglas production function, if we divide both sides of this Cobb-Douglas production here by L, then we get this thing here. So capital Y over L is equal to the right-hand side here. And so if you do a little bit of algebra, you can see that that's going to simplify to y is equal, little y, excuse me, little y is equal to A times K over L, all to the 0.3 power. And so we're going to simplify that to this thing here, y is equal to a times little k to the 0.3, and I probably just wrote over that. So that's equal to, if we make this definition where little k is simply equal to the total capital stock available per worker. Okay. So this sort of simplifies this problem now. We've isolated what we care about, which is the standard of living, and now this really tells us there's two channels through which we can improve the standard of living. Increase TFP through that A parameter, or increase the amount of capital per worker, little k. Those things are going to help us improve our standard of living. And so this is just repeating what I just said. The amount of output per worker or per person, which is what we care about, depends on the level of technology or total factor productivity, as well as the level of capital per person. And so the Solow model, again, is designed to think about this notion of capital accumulation as the primary channel through which we can think about standard of living. And so it's going to build a basic model which tries to understand how capital per person, the dynamics of capital per person, and how we can explain those dynamics with some basic, with a few basic assumptions. The one important point to underscore here is that in this basic Solow model framework, we assume that the labor force and the level of technology are exogenous, okay? And in particular, with the level of technology being exogenous, as we talked about previously, that's an important driver of growth. And so this basic Solow model framework doesn't allow us to explain why or where technology comes from. Yet it's an important driver of growth. And as we'll see later on, technology is an important contributor to sustained growth over time, which this basic Solow model doesn't allow us to explain. So to preview this Solow model, which I'll get into details in the next video, the countries with higher savings rates, as it turns out, excuse me, countries with higher savings rates are going to have higher amount of capital accumulation, and as a result of that, they're going to enjoy a better standard of living. The basic intuition is, as an economy, if you accumulate more capital, that means you have more in the production process, which means in that production function, you can spit out more output as a result, okay? And then the second thing that we underscore here is that we can actually control for population growth rate. So if, again, we assume population growth rate and the labor force is exogenous, we can play around with that, and what we'll see is that higher population growth rates end up diluting the capital stock, and that results in a lower standard of living. Again, very simply, if we have higher growth rates in the population, we have a higher workforce with an existing capital stock, that dilutes the amount of capital that each worker has, and therefore each worker is less efficient in production. And so overall, that's going to result in a lower amount of output produced relative to the workforce, and therefore lower the standard of living. Pardon me. A few limitations to the Solow model, in the basic Solow model. So first of all, it can't explain sustained growth in output per person over time. And that's an important shortfall of this basic model, which, as I said, is going to be, there's a model, an extension to this model, which Chapter 7 deals with endogenous growth. And so the intuition behind this basic Solow model is that we're going to reach some equilibrium, which we'll call a steady state. But once we get there, we'll just stay there. And so what that means for output per worker is that output per worker is no longer going to grow. It's going to grow for a while till we get to the steady state, and then it's going to stop. And so that doesn't allow us to understand why most of those countries that we saw on the graph previously had increased output per capita over time. So it goes against this, the understanding of this basic model. And then the other issue that's that's related to the first point is that it doesn't allow us to explain very well cross-country variation in total factor productivity, which is an important source of growth. If we think about the basic framework of society and global dynamics and knowledge, if country A is developing technology and using it really well to grow, then theoretically any other country could adopt that same technology and grow just as well. But we don't see that in practice. And so the question is, what's underlying these differentials in total factor productivity, which again are an important source of growth and living standards. And that's something that the basic Solow model framework doesn't do. But as I said, Chapter 7 again deals with this issue in thinking about what are the underlying sources of variation in total factor productivity. And so I invite you to take a look at that chapter to answer that question. Thank you.